Good morning, students. Let us start. Let us continue the remaining two properties of circular motion. In the last lecture, we have seen the definition of radius vector and angular displacement. Today, we will study two more properties of circular motion. The third one is what? Angular velocity. Let us understand what will be the definition of angular velocity. What is the definition or the formula for the general formula of velocity? Distance upon time. That is for linear velocity. If it is angular velocity, the distance upon time, that distance is going to replace by the displacement. That is what? Angular displacement. Displacement or distance is going to replace by what? Angular displacement. And time, as it is, it remains as it is. So students, from the formula we can see angular velocity, symbol of the angular velocity is what? Omega. The definition of angular velocity is what? Is a rate of change of angular displacement. So students, in the exam, how we will write? Angular velocity of a particle performing circular motion is defined as is a time rate of change of limiting angular displacement. Rate of change of what, students? Angular displacement. Students, what is the dimension and unit of the angular velocity? What is unit of theta, that is angle, is always been radian, and as you know, unit of time is always second. So what is unit of angular velocity? Radian per second. Students, what is the dimension? If I observe there is no length parameter over here, there is no mass parameter over here, only time is there upon, and that time is in what? In the denominator. So what is the dimension of angular velocity? L0, M0 and T raised to minus. Students, since angular velocity is a vector quantity, it has direction. A direction of the angular velocity is given by right hand thumb rule. So students, here we took axis of rotation in the right hand. Curved fingers represent what? Direction of the motion or circular motion of the particle. Outstretched thumb represent what? Direction of the angular velocity. If curved fingers represent direction of angular velocity, so is curved finger represent what? Direction of the circular motion, and this axis is in the right hand, then outstretched thumb represent what? Direction of the angular velocity. So students, direction of the angular velocity is given by right hand. This is basic vector representation of the direction of the angular velocity. Let us complete, or let us do the last parameter of the circular motion. The last parameter of the circular motion is angular acceleration. Students, angular acceleration, the definition of the angular acceleration is a rate of change of angular velocity. It's a rate of change of angular velocity. Rate of change of angular velocities. Initially, if I consider omega 0 is the initial angular velocity at time t equals to 0. If I consider omega is another angular velocity in time t, then omega minus omega naught upon t minus t naught will give us what? Angular acceleration. Students, let us study the definition of angular acceleration. The average angular acceleration is defined as is the time rate of change of angular velocity. In mathematically, we can write alpha is what? Omega upon t. Students, let us study the unit of angular acceleration. Unit of what is omega? Unit of omega, radian per second, and there is one more time quantity over there. So radian per second means what? Final answer is the radian per second square. What is unit of angular acceleration? Radian per second square. Similarly, we will write the dimension. There is no length parameter. There is no Mass parameter over there, only time is there. So L raised to 0, M raised to 0, T raised to minus 2 is the dimension. Students, since angular acceleration is a vector quantity, you can see here is a vector quantity, therefore direction associated with the angular acceleration. Again, same rule we are going to apply to represent the direction of the angular acceleration, that is right hand thumb rule. If I took axis of rotation in my right hand with curl fingers represent what? Direction of the circular motion, then outstretched thumb represent direction of angular acceleration. Students, this is a last parameter of the circular motion. Thank you very much.